Okay, so I'm doing a talk on the NES. This device, the Nintendo Entertainment System. Who of you doesn't know the Nintendo Entertainment System? Okay. It's probably the greatest console ever made. And I'm not exaggerating here. It's Nintendo's first video console that went to European and US markets. It has all of the classic games, Super Mario 1, 2, 3, the games you all probably have seen or were jealous of your friends. It all has it all. So without further ado, let's start the talk. Oh, there we go. Okay, let me just switch to the NES. Is it working? Is it working? There's a red light. That's a good thing. Oh, this is so exciting. Yes? Should I just try and turn it off and on again, right? Yeah, that's the classic thing. Like if it doesn't work, you go, yeah. It doesn't actually do anything. It's just, oh man. I tested it just before, and it was working. So I think I will just have to use an emulator. That sucks. The cable is plugged in. Everything is plugged in. I can even show you Super Mario working, but it's not working. Okay, well, that's fine. I'll just use the other thing. Maybe I can go like this. Does that work? Nah. Okay, fine. Never mind. Yeah. Well, if you really want, I can show you afterwards, or you can go online and find. I did this talk another time somewhere, so you can just look at that. It was super exciting. Really. I'm trying to say this deadpan. Okay. So this is a Ness Rom running on my emulator, and I'm going to talk about the next thing, programming the NES with JS. And you're like, what? JavaScript won't run on a console, or not on a NES at least. You're right, it won't. It's super slow, and you will never, well, if you do, congratulations, you have spent a lot of hours on nothing worthwhile. But I'm going to show you a bit on why I started programming the NES, and how you can also do that with the abstract syntax tree analysis. Yeah? Okay, so I'm Fritz. I am not a computer scientist. I did not do anything informatics related. I did sociology at the university and some soil erosion. So naturally, I ended up in engineering, right? I do a lot of things besides programming. I could enter a job title for this conference, and I entered boulanger, which is the French word for baker. I recently started sourdough bread baking, and I love it. So I do that. I'm also in a band called Cheeses of Mexico. You can find us on cheeseofmexico.com, of course. But I work for a company that does stuff, and I program the stuff. And now I'm transitioning into teaching. So you'll soon find me at a local technical college near you, if you're in Arnhem. Okay, there you go. So this is me. I've got 99 repos, but I ain't finished none. Like, I've got all of these projects on my GitHub, and you probably have some projects as well, but I actually tried to finish this one, and I didn't really do that yet, but I got the slides working, and I got this talk working. So if you are like that, don't worry, it's fine. It's actually very good. I'm going to say something about that. Okay, so I'm going to talk about three things. I'm going to talk about constraints, doing new things, and I'm going to show you a little demo, if I still have time. Okay, so I really like constraints, and especially the NES constraints are this device is one of the most constrained devices you will ever encounter. It has a 1.79 megahertz CPU that runs 6502 assembler. If you don't know that, that's not a problem. It's a very old version of assembler, which also ran in the Commodore 64 and some other old computers. It was very cheap at the time. still is very cheap. You can buy it for $10. You can buy a 6502 CPU. The NES had a audio processing unit in it, which is really perfect for synth music. So if you're into synth music, you can do 4 channels of like saws and triangles, and then 1 channel of beats. So those sounds, you know, the Mario sounds. But that wasn't really a big thing. I mean, the CPU and APU, wow, we've got a CPU now, but it's still very slow. So in 1985, that wasn't special at all. But what was very special was the PPU, the picture processing unit. It ran a little bit faster, but it also could show sprites. So 8 by 8 pixel images, and it could stitch them together, and it looked like a little person was walking. It could animate. And it could do scrolling of backgrounds, so either horizontal or vertical. Okay. So it also had only 2 kilobytes of RAM. Yeah? Just going to say that. Stop there. A resolution was 256 pixels by 240 if you had a PAL NES. So if you're on NTSC, so all the Northern American countries had NTSC as a TV system, it was 224 pixels. NTSC ran at 60 hertz, so that's 60 frames per second, and PAL ran at 50 hertz per second. So if you have a cartridge which isn't region locked, and you put it in like an NTSC cartridge, and you put it in a European NES, it will run slower. The music will be running slower. It's super funny. It only has 64 colors, and when I say 64 colors, I actually mean 56. It's not because I can't count. It's because there are like 7 shades of black on the NES. So, yeah. Per sprite or per tile, you can only show 3 colors. Actually 4 colors, but 1 color is the background color. So that also doesn't really count. And when I mean a sprite color, that's this one. So if you look carefully, most games will only have 3 colors per character. So Mario only has 3 colors. Mega Man did something special and has more colors, but I mean, Mega Man. And there are only 8 buttons on the NES. There's a left, right, up, down, select, start, BA. And you can do everything with it. It doesn't have a keyboard, nothing. It's just a very simple device. Then it can only show 8 sprites per scan line. Okay, so when I say a sprite, it's not this whole image. It's just this little tiny part, because this is actually 4 sprites. So if you have something like Super Mario, you will have Super Mario, a Koopa, I don't know, something else. And if you would have more than 8 sprites per scan line, it would leave 1 out. So some programmers would start flickering, so you could see it at some frames, so you would have the feeling it would still be there. Then there's a Ness Rom. You probably downloaded these things very legally at some not dodgy site to run in your emulator. And that is actually a combination of a character and a program ROM. And I can probably show you this. So on the one side, it's the character ROM. On the other side, it's a program ROM. Okay. So constraints are really cool, but they also really suck. So I'm going to switch to normal presentation slides now and not something on the NES because, you know, it just doesn't make sense. Okay. Here we go. Where was I? Okay. So who of you knows which game this is from? Super Mario 2. Okay. And on which platform did this particular image come from? Super NES. Okay. Yes? Super NES? You're still with me? Okay. And so what was this game originally called? Doki Doki Panic. Yes. You, sir, earned a 1-up. Okay. This is what it looked like on the NES. So you can see a lot less colors and no animation because you need to cram all that information into 8 kilobytes of ROM. Okay. So constraints are also the bomb because constraints make you think about systems or devices in a whole new light. You need to work around these constraints to get something done. So this game, Kirby's Adventure, is the most astounding piece of work made on the NES because it had save games, it had all these colors, and it would still run smoothly. It's perfect. So why I talk about constraints is because I think they're beautiful. Twitter has constraints of 140 characters per message. Some people use these Twitter messages to create a very long blog, but I don't think Twitter was meant for that. Another form of constraints is emoji. Like you can only convey so much in one emoji, right? And programming is a very big constraint. You only have 4 if you have some keywords that make you, like, let's say it's 20 or 30 keywords, if you're very lucky or very unlucky with a strange language. But with those constraints, you can make anything, sort of, right? So I love constraints. This are all the images that are used in Super Mario. Super constrained. And you can see that they really had to be creative with creating the game. For example, if you look really closely, you can see that the clouds and the bushes are the same. You can't see that on here, but if you play the game, you can see the clouds and the bushes are the same combination of sprites, just a different color. So super creative. And you don't actually see it unless you see it, you know? So now you will never unsee it. Okay. And why do I talk about constraints? Because we encounter them every day. We can encounter them in browsers. It is IE. I mean, we have to work around IE, not so much anymore though, but it is a constraint. And we have clients that set boundaries for budget or for date, or they want to do certain things. And we're not always aware of it, but we always have constraints. So try to find, wherever you are, try to find out what your constraints are, and yeah, and see if you can work with that. If you're really into constraints, you should also check out Amanda Glossen's talk about constraints. I put it here in the link, so you can go to it. Okay, now I want to talk about doing new things. And I used the background image is a new game, or relatively new NES game that came out like in the last few years. And we actually have the creator here. Dustin. Yay. So these games are still being made. And I think that is very cool. It's a very strange niche market, of course, but it's still happening. And why do I want to talk about new things? Because we have brains, of course. And our brains, you know, you're told that once you're 25, man, your brain capacity will only go down. This is the highlight for you. This is it. Which is true in some way, like it won't mature anymore. But it doesn't mean that your brain is done. It still can learn new things, and it can learn new things very quickly if you keep learning new things. It's actually, the more you learn new things, the more you can acquire new things. So actually, a fun fact is that if you have done a lot of new things on a day, or like met new people, or been at a new place, if you go home that day, or I don't know, to your hotel, and you learn, you pick up your textbook or the language you're learning, you will store that information better because you did a lot of new things and already expanded your brain. So if you go home, dive into your textbook and try to acquire all that knowledge. And when I do talk about new things, I also talk about not invented here. People usually say this as a bad thing, like, well, like not invented here means that you have to recreate everything because you think you don't trust other people's work, something along that line, right? So I actually like reinventing the wheel. Not because I think the wheel sucks or because I think I can do better, but it's a very educational experience. So if I write my own front-end framework or back-end framework, it's not because I think I can do better, because I will never use my own stuff in production. I know how I code. But I now know what those layers of abstractions mean in other frameworks, and I know what kind of problems I need to overcome. I already said that just now. I said removing abstractions. What I mean with that is sometimes when we think of a backend framework, it's just like this thing where you toss data at and stuff comes out. Okay, so I have kind of an abstract way of looking at that. The same was for me with sourdough bread making. It was like, okay, well, there's this yeasty thing and it smells a bit, and you toss flour at it, oven. Okay, done. Not at all. It's a lot of work. But doing that thing, starting to acquire that knowledge about that, removes that abstraction from it. And you can actually have more respect for people like bakers or plumbers or web developers or designers. If you actually learn to do this thing, it will remove the abstract thought of what it is, and you will learn more about it. If you are into that, I also linked another post over there. what I also learned was open source is very great, because I thought I was being very original. I was like, okay, I'm doing JavaScript and doing NES. Oh yeah, I must be so cool now right now. But that wasn't the case. There were lots of people actually already doing this. A lot of people wrote emulators, but there were also some people writing stuff to actually make the games themselves. So I found this one guy called Michael Matuzak. He's in LA. And he did like most of the work for what I am showing you. He wrote this abstract syntax tree analysis of JavaScript, and then replaces all the JavaScript with NES assembler. I'm going to show you in a bit. And it uses Falafel, which is a pretty great library. So if you want to get into abstract syntax trees, try Falafel. It's pretty fun. And also, if you want to get into the chip music on the NES, npm install Nestle assembler and Nestle sound, because you can then make your own chip music. Yes, I can see Daijiro is like, yes, 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 let's do this. Okay, so demo time. I created a little package called Ruhr.js, because I also did this talk at another conference, so sorry about that. And you can see here there's a few scripts. This one compiles the JavaScript to, or analyze it and then outputs an assembler file. This one compiles the ROM. This one creates images. And this one just runs everything and then runs the, what? Bigger? Yes, thank you, Thomas. How much bigger? Like this? Like that? Okay, there you go, thank you. So let's just run npm run build, right? So it does start, compile, and runs the emulator. So if all goes well, yes, there we go. My background algorithm was kind of slightly off, so you can see it shifted. But I made this. This is made from a JavaScript file. So let's look at the JavaScript file. Oh, close it. Okay, so this is the JavaScript file. It has a header, reset. It's basically like HTML and CSS, right? Then it says background palette, sprite palette. And we're going to actually change the palette. So what you saw was a light green background, right? Let's try a different background. So give me a number code, please. 12. Sorry, 12. Are you going to see that? It's light green and blue. Okay, I'll try. Okay, let's do this. Okay, thank you, Atom. 12. Boom. npm run build. It's blue. There we go. Okay, how am I doing on time, by the way? How much more time? 12 minutes. Whoa, okay. So I can do some more demos. If you know which game this is from, you can get the POW block or the, what do you call this? The upgrader. I don't know what you call this, the mushroom. Do you know, does anyone know which game this is from? No. It's, yes? Mr. Gimmick. This is one of the rarest games on the planet. You will, if you find a cartridge like this, you will like, it's worth $2,000, so, yeah? Oh yeah, backgrounds, I was talking about that. You still get the, I mean, Dustin is cheating, he's a NES developer. Anyone else wants the POW block? Yeah, there you go. Sorry, almost hurt you. Okay, backgrounds. So I use this tile map editor I like called Tiled. There we go. So I made this. This is the background you just saw. Remember, I can show you again. So this is the background, only with, I kind of messed up the algorithm. And this is the foreground. So this little dude does not have anything to do with backgrounds. Okay, let's go back to the background. And let's add some more JS logos, because who doesn't love JS? Am I right? Am I right? Yeah. Okay, so save. Close this one. And I actually wrote something that extracts the CSV data from the tile map file. But it wasn't working this morning. So I'm just going to go like this, copy, paste. So copy all this data. So this data is just like the tiles. The numbers corresponding to the tiles in the image. We put that somewhere here, and then we have all these JS logos, if everything goes well. Live demos, I'm sweating. Sorry. Okay, JS logos. Okay, let's do one more thing. Thank you, by the way. Let's do one more thing, and let's change the sprite. So do a sprite swap. So I use this image is the input to create the character ROM. And you see this little dude is, oh well, I closed it there. Is this little dude. Yeah? Everyone following it? Yeah. Okay, so let's swap that with Kirby. So we, boom, select Kirby. There we go. Paste it, put it in the place of the other guy. Or girl, by the way, I'm sorry. I'm being so not. Yes. Okay. And if all goes well, oh no, we first need to run the image processor. Okay, run the image processor. Now we have Kirby. Yay! Okay. Okay, now I need to hurry up. Okay, takeaways. What I take away from this experience, C and assembler are totally learnable. I do not have a background in computer science or something like that. I did not know how chips worked. I did not know binary counting. I did not know bit swapping, byte swapping. I did not understand all of these things. But I could, it was really easy to learn these things when I dug into this. It's also the removing abstraction. I thought it was this huge, big problem I needed to solve, but it's not. It's not that. I can actually do hexadecimal counting now, which I think is pretty cool. What I also took away is that strong community draws people in. So the NES dev community is super, super nice. You go to the forum, you post something online, and or a question or something. Within a day, you will get a response with someone explaining to you, okay, this is how it works. And sometimes, I mean, there's always trolling on all forums, but usually it's pretty good. And it really helped me to keep going with this because it was kind of a difficult project. It took me like a few months to get this thing going, but it really draws people in, and always lower the barrier to entry. I went to some blogs and they explained to me how to run the NES assembler, but they didn't explain how to install it or where to find it. So I don't know, I felt like I was running in circles trying to find these things. But if you do come across things like this, write a blog post about it, share it somewhere, and the next person after you will not run into this barrier, hopefully. And constraints force creativity. I think that's one of the most powerful things I've learned about that. And also NESDev has really cool people, like Dustin over here. Then I want to thank some people. These are the guys that wrote the libraries I used. And I emailed Michael Matuzek back and forth about using his GitHub repo, and it was all fine. So, thank you. That was my talk. And I don't know if I have time for Q&A. Let's see. I actually have no idea. Like 5 minutes? Yeah? If anyone has a question or an answer, or just wants to play Super Mario online, or like over here, that's also fine. No? No questions? Well, yes?
Where can you find that hardware?
Oh, this, where I found this.
I mean the NES.
The NES. Well, this one, my dad bought this for my brother and I when I was 12. And it's funny, like the PlayStation 1 or 2 was already coming out. No, PlayStation 1, I'm not that old. I'm not that young. And he bought us this on like some yard sale, and I was really happy because it's. But you can still buy them on eBay or like the Dutch version of eBay Marktplaats. If you're around here, use marktplaats.nl. It's really good, and you can buy it I think for like 60 euros. Yeah, and this one also cost me about $60 in total shipping, packaging, everything. Yeah. So, anyone else? No, I had to buy a cartridge. I first had to find out where to find a cartridge. But there's still people making these. They make the plastic shells somewhere in the States. This guy solders, made these PCB boards and has them manufactured somewhere. Costs about $20 to have this, and then you also need the programmer to program the ROM onto this thing. But there are also other alternatives. If you go to my blog, like blog.fritzvd.com, fritzvd is like Fritz VD, not venereal disease, but just it looks like it. blog.fritzvd.com. You can find the first, I think the first or second article is about the NES, yeah? Okay. Cheers. Thank you very much.